What's the difference between the Microsoft Surface RT and the Surface Pro? What do all these things have in common? Why does Apple have one set of apps for mobile devices and different apps for Macs?
This video will try to break it down by looking at something called processor instruction set architectures. Most digital devices sold today use one of two architectures. Home computers built over the past 3 decades mainly run on the x86 platform. This starts all the way back to the Intel 8086 CPU. From the gates, the goal for Intel was full backward compatibility. It's both good and bad. Good for software developers because they get a larger customer base as new chips will still run old software, but bad for efficiency because the architecture got messy with all the legacy support that's built in. Think Hoarders, Episode CPU. Some people call x86 a CISC architecture because it can do multiple steps within a single program instruction. 1985 was a big year for CPUs. Intel launched its first 32-bit processor, the 8386. Bits are important because the CPU sees them as a unit. If it can handle more bits at a time, it can quickly perform more complex calculations. Also, these bits refer to a location in memory. The more bits, the more memory, speeding up applications. 32-bit was great for 15 years, before it became a bottleneck. Problem? It could only access up to 4 gigs of memory. In 2003, AMD beat Intel to the market and released the first consumer 64-bit CPU that could access up to 4 million gigabytes of RAM. Intel fired back with the Pentium 4 Prescott, but Intel hit the clock speed wall, where increasing gigahertz on x86 chips caused more problems than it solved. It wasn't until the Core lineup released in 2006 that Intel focused on getting more done per clock cycle. This is why they are more powerful than ARM chips today. On the downside, they still require good venting and cooling. ARM processors speak a different language. They're based on a RISC architecture that keeps the chip small and cheap by focusing on completing simple instructions really fast. If x86 is Chinese with thousands of characters, ARM is like English with only 26 letters. When Intel introduced its pricey x86 32-bit processors in 1985, ARM launched its cheaper 32-bit architecture. Since 1985, the core design hasn't really changed that much, with just 35,000 transistors, compared to 1.4 billion in the latest Ivy Bridge Intel x86 chip. In the late 1980s, Apple invested in the company, and ARM Holdings was born, making money by licensing designs to tech companies so that they can make their own CPUs. With the explosion of the smartphone and tablet industry over the past 5 years, ARM is in the spotlight again because its chips are simple and use less power. As x86 is the platform for desktops and powerful notebooks, ARM is the standard for mobile devices where battery life is crucial. As of early 2011, 15 billion of these chips exist in the most popular electronic devices ever produced, and just about every major hardware company uses ARM processor designs. Lately, tech companies have been building systems on a chip that integrate all the parts of a computer onto a single piece of silicon, like NVIDIA's Tegra, Texas Instruments OMAP, Samsung's Exynos, and Apple's A-series. Other companies have an architectural license to design their own CPU cores, like Qualcomm's Snapdragon and DEC's StrongARM. On the software side, ARM is supported by Unix-like operating systems like iOS, Android, and Linux. Last year, even Microsoft, the king of x86 for 30 years, announced support for ARM in Windows 8. But the challenge for software developers and consumers is that applications written for ARM-based devices cannot be read by an x86 device without some translation, hence the different sets of software. But we're starting to see signs of these markets coming together. Intel is looking for ways to lower power consumption on notebooks by creating the Ultrabook standard with processors that integrate graphics chips, reduce power requirements, and ultimately result in multi-chip packages. In late 2011, ARM boosted performance by introducing its first 64-bit architecture. In the future, we'll start to see these 64-bit processors that could access gobs of memory, putting today's devices to shame. So I hope this video frames the war in the world of processors. Subscribe for updates as this David versus Goliath battle continues. Thumbs up if it helped, and of course, thanks for watching.